Good morning students, welcome to the EduSet program. Myself Dr. Raman Rani Mittal, lecturer in chemistry from Government Polytechnic College for Girls, Patiala. Today I am going to deliver you a lecture on drinking water and its purification. This lecture is for the first semester students of all diploma streams. So, the main contents of this chapter are drinking water and its characteristics, purification of water for domestic use. Under this, we will divide this purification into two parts: removal of suspended impurities by storage, screening, sedimentation, coagulation, filtration, and then removal of microorganisms by boiling, chlorination, ozonization, adding of KMnO4 UV rays and by aeration, and then desalination of sea water. Now, before studying drinking water, let us have a look on water. All of you know that water is essential for all forms of life. Of the total water available on Earth's surface, 97% water is locked in is available as sea water or in inland saline water. This water is not useful for drinking purposes. Only 2.7% water is a fresh water, and of this 2.7%, only 0.3% is available for human use. So, the need of R is to use water economically and carefully. Water is available from different sources like rainwater, river water, sea water, spring water, well water, etc. Water contains so many impurities. These impurities can be suspended impurities, colloidal impurities, or maybe dissolved impurities. Suspended impurities are those which are available, which we can see through the naked eye, and they remain dispersed in water, and these suspended impurities can be in the form of algae, fungi, protozoa. It can be in the form of silt, clay, minerals, or organic matter, etc. Suspended impurities, however, they can be partially removed by filtration. Colloidal impurities, which are having such size that they cannot be seen with naked eye and they cannot be filtered. So, colloidal impurities are removed by special treatment. Dissolved impurities can be in the form of salts, it can be in the form of gases, it can be in the form of metal atoms, or it can be in the form of vegetable matter or organic matter. So, we cannot use such waters which is containing so many impurities for drinking purposes or for human use. So, drinking water is, what is drinking water? So, water which is fit for human consumption is called as drinking water, or it may be called as the potable water. So, what should be the characteristics of drinking water? It should be clear, colorless and odorless. It should be pleasant in taste. It should be perfectly cool. Its turbidity should not exceed 10 ppm, because suspended impurities make the water turbid. So, there should not be any suspended impurities. Water should be free from objectionable dissolved gases like hydrogen sulphide. It should be free from objectionable mineral metal atoms such as lead, arsenic, chromium or manganese, salts, etc. Its alkalinity should not be high. So, its pH should be in the range of about 7.5 to 8. It should be reasonably soft. Its total dissolved solids should be less than 500 ppm. It should be free from disease producing microorganisms. So, these were the characteristics of the drinking water. Now, we come under the heading purification of water for domestic use. Natural water available from different sources, it may contain different types of impurities and that too in different amounts. So, the treatment given to natural water to convert it into potable water or drinking water depends upon the type and amount of impurity. So, the process of removal of undesirable matter, that is impurities from water, to convert it into potable water is called as water purification. So, what is water purification? To remove the impurities, undesirable matter or impurities, and to convert water into the drinking water is called as the water purification. So, water purification involves two main methods: removal of suspended impurities and then removal of microorganisms. Removal of suspended impurities can be done by following 5 methods: storage, then screening, then sedimentation, coagulation, and then filtration. Whereas the second part of purification involves removal of microorganisms. This step is also called as the sterilization. Under this heading, we can treat water by boiling, by chlorination, and under the heading chlorination, we can sterilize water by using chlorine gas, by using chloramine, or by adding bleaching powder. Sterilization of water can be done by ozonization, it can be done by adding KMnO4 or by UV rays, ultraviolet rays, or by aeration. So, we will study the two main methods of purification of water by one by one. So, first of all removal of suspended impurities. So, first of all storage. So, the water which is to be purified, it is collected in big tanks, then it is taken for screening. In the heading of screening, water is passed through screens having large number of holes. Water is passed through screens in which there are large number of holes. And when water passes through these holes, it is passed through a very slow speed. Then water passes through holes and floating matter, suspended matter, it leaves behind. So, floating matter like leaves, wood pieces, dead animals, or any other floating matter, etc., they are retained on one side of the screen, whereas the water, clear water, passes through the screen. So, this step is called as the screening. Then after screening, water is taken for sedimentation. Sedimentation is the process to keep a liquid undisturbed for a long time, so that its suspended floating impurities, they settle down and clear liquid comes upward. So, same process is applied for water, that water is screened water. This is the third step. So, screened water is kept undisturbed for hours or maybe for days in big tanks. Due to force of gravity, most of the suspended particles like clay, sand, silt, they etc., they settle down at the bottom of the tank. Clear water taken out of the help of siphons or pumps. So, settling as that settling tanks in which sedimentation is taking place. So, these tanks are cleaned periodically, time to time, to remove settled suspended particles. The particles which settle at the bottom of the tank, they are cleaned from time to time. So, when water contains fine clay particles and colloidal matter, it becomes necessary to apply sedimentation with coagulation for removing such impurities. Because fine clay particles and colloidal matter, they do not settle down immediately, or we can say they cannot be purified by sedimentation alone. So, we have to apply coagulation also. Sedimentation with coagulation, what is this process? It is the process of removing fine suspended and colloidal impurities by the addition of requisite amount of chemicals. These chemicals are called as coagulants to water before sedimentation. So, in coagulation we add certain chemicals. Coagulant, what is the function of these chemicals which are called as coagulants? Coagulant, when added to water, it forms an insoluble gelatinous flocculent precipitate which descends through the water, absorbs and entangles the very fine suspended impurities, forming bigger flocks which settle down easily. So, in simple words we can say that the fine particles or colloidal matter, they do not settle down under the force of gravity. So, to remove such particles we have to add certain chemicals. These chemicals are called as coagulants. These coagulants, when they are added to water, they form precipitates which are large in size, and these precipitates, they absorb or they catch the fine suspended impurities. As a result, the size of the particle increases and it becomes heavier and it settles down under the force of gravity and water becomes clear. So, let us have a look on coagulation in detail. The process of removal of fine suspended particles and colloidal impurities like clay by adding chemical which is called as coagulant in requisite quantity is called as coagulation. So, why we apply coagulation? Because certain particles, they do not settle down under the force of gravity. So, to remove such particles we have to add chemicals. As a result of coagulation, fine particles get adhered to each other, forming large masses. Large masses means they form particles of larger size. This process is followed by sedimentation, in which these large masses settle down due to their own weight. So, because these particles, they become heavier and they settle down. So, the substances which can be or chemicals which can be used as coagulants are certain. Number 1, alum, its formula, it is a double salt of potassium sulphate and aluminum sulphate. So, formula of alum is K2SO4 Al2SO4 thrice 24 H2O. The second chemical which can be used as coagulant is ferrous sulphate, having formula FeSO4 7H2O. And the third coagulant can be sodium aluminate, NaAlO2. The addition of any one of these coagulants in requisite means required quantity, how much is required. So, the addition of coagulant in requisite quantity is also called as dosing. The fifth process, first one was storage, second one was screening, then sedimentation and coagulation. The fifth method is filtration. These steps are done one by one. So, after coagulation we are proceeding for filtration. The process of removing colloidal matter and most of the bacteria, microorganisms, etc., by passing water through a bed of fine sand and other proper sized granular materials is called as filtration. So, filtration is done by passing water through the bed of fine sand. So, it removes colloidal matter, bacteria and also microorganisms. So, filtration can be done by using sand filters. The filters used for filtration are, they are of two types mainly. Number 1, gravity sand filters, and number 2, pressure filters. So, we will study these filters one by one. Gravity sand filter. A sand filter consists of a thick top layer of fine sand placed over coarse sand layer and gravels. So, we can say in this filter there are 3 layers. First, lowermost layer is of gravel, then above it is coarse sand, which we can say thick sand, and then top layer is of fine sand. Provided with an inlet for water and an under drain channel to the bottom for exit of filtered water. So, this filter, gravity sand filter, there is a inlet for water on the lower side, and on the other side there is a exit for the filtered water. Sedimented water, the water which is coming after coagulation and sedimentation, it enters the gravity sand filter and it is uniformly distributed over the fine sand bed. Water passes through different sand beds, suspended impurities are retained by these beds. During filtration, the sand pores get choked due to retention of impurities in the pores, and rate of filtration gets decreased. When the rate of filtration becomes slow, the working of filter is stopped and the surface layer of top sand bed is scraped off and is replaced with clean sand, and filter is put back into use again. The scrapped sand, which is containing certain impurities, is washed with water, dried and stored for reuse at the time of next scrapping operation. So, above method is best suited for municipal water supply. So, we can understand this gravity sand filter through this diagram, that this is the gravity sand filter. The lowermost is of layer is of gravels, जिसे हम बजरी कहते हैं. इसके ऊपर coarse sand, मोटी sand, coarse sand, and then the top layer is of fine sand. This is the inlet for sedimented water. Water after sedimentation, it is passed through this inlet and it is distributed over the whole of the layer of fine sand. Water, it seeps through this fine sand layer, then coarse sand and gravels, and filtered water, it comes out through this way and it is taken out from this outlet. So, during this process, during this filtration, because impurities they remain on this layer, fine sand layer. So, the pores of this layer through which water can seep through, this layer becomes clogged, or we can say it becomes choked, and when it becomes choked, so the further rate of filtration decreases. So, with time, with certain time, when rate of filtration becomes quite less, so this layer is scraped off and it is replaced by another clear layer. So, scrapped layer is then washed and dried and it can be used again and again. So, you can see it, when the rate of filtration becomes slow, working of filter is stopped, surface layer of top sand bed is scrapped off and replaced with clean sand, and filter is put back into use again. The scrapped sand is washed with water, dried, stored for reuse at the time of next scrapping operation. So, this method is best suited for municipal water supply. Then the second type of filtration is pressure filtration. A pressure filter consists of 3 layers. The basic idea of filtration is same in all the cases. So, here again we have 3 layers: lowermost bed of pebbles, middle bed of coarse sand, and the top layer of fine sand. 3 layers, first one lowermost of pebbles, coarse, and then fine sand. It is kept in a vertical steel cylinder. These 3 layers, they are kept in steel cylinder. Above the fine sand layer, there is a layer of alum. Top layer above, which is of fine sand, above this layer there is alum. Alum is, you have seen just now, it is a double salt of potassium and aluminum. It is working as a coagulant. water under pressure is forced into the tank from the top. Water which is to be filtered, it is passed into the tank from the top. Alum layer forms slimy layer on the filter bed which removes colloidal and bacterial impurities. It also removes germs. Clogged pressure filter is cleaned by backwashing. This method is also useful for municipal water supply. So, you can see here vertical pressure filter, this is the diagram for vertical pressure filter. So, lowermost layer is of pebbles, then second layer is of coarse sand, and then top layer is of fine sand. Above this fine sand there is a layer of alum, aluminium hydroxide, and from here raw water means sedimented water, water after the sedimentation it is passed here, and water first of all it passes through the layer of alum where the colloidal and other suspended impurities they or even microorganisms they are trapped in this layer, and then water is passing through fine sand, coarse sand and pebbles, and clear filtered water is collected at the bottom of this cylinder from where it is taken out. So, we can filter water by this method on a large scale. So, that is why we say okay, this is useful for municipal water supply. So, domestic filtration, the filtration which we can use, the filters which we can use at our homes. So, such type of filtration may be termed as domestic filtration. So, in domestic modern domestic filters, Pasteur filters they are generally used. So, in such filters water percolates through unglazed porcelain filter tubes. Impurities they remain outside the tubes. Clear water free from suspended come out of the tubes and is collected in the reservoir from where it can be taken out of the tap. So, this is the picture for Pasteur filters. So, it is again in the cylindrical form. In the center of the filter we have two tubes which are made up of unglazed porcelain. From top we can add impure water, and the impurities they remain outside these tubes, whereas clear water it can enter through the pores of these tubes which is of unglazed porcelain, and clear water can be collected at the bottom of this filter from where it is taken out. So, this method is this domestic filtration is used, or we can say Pasteur filters are used at homes, and this method is useful for domestic filtration. So, this was all about the removal of suspended impurities. Then the second step of water purification is removal of microorganisms or sterilization. So, because by this method we remove organism, germs etc. So, this step is called as the sterilization. Water after passing through sedimentation, coagulation and filtration operations still contains small percentage of pathogenic bacteria which are disease producing. So, they are called as pathogenic bacteria. So, even water which we are receiving after filtration, it is clear, but it is not free from microorganism. So, it may cause disease. So, it should be made disease free by sterilization. So, water to be used for drinking or municipal purposes must be free from disease producing bacteria and microorganisms etc. So, the process of destroying or killing disease producing bacteria, microorganisms etc. from water and making it safe for use is called as disinfection. This is also called as sterilization, may be called as disinfection, because by this method we remove or we kill the bacteria, microorganisms, etc., and making water free from these organisms. So, this process is called as a disinfection. So, this disinfection can be done by certain chemicals. So, the chemicals or substances which are added to water for killing bacteria are known as disinfectants. So, what are disinfectants? That the chemicals which are added to water for killing bacteria, microorganisms, etc. So, they are disinfectants. So, we will study these disinfectants, how we can make how we can sterilize water with the help of different disinfectants, we will see just now. So, disinfection of water can be carried out by following methods. The most primitive method is boiling. It can be done by chlorination, in chlorination by using chlorine gas, or it may be by using chloramine or by adding bleaching powder. Then by ozonization or by adding KMnO4, by UV rays or by aeration. So, we will study all these methods of sterilization by one. So, first of all, boiling. By boiling water for 10 to 15 minutes, all disease producing bacteria are killed and water becomes safe for use. So, this method we use at homes most of the times. So, the advantages of this method are, it is simple and a very effective method of purification or disinfection. This method will kill many waterborne bacteria through the intense heat, because boiling of water is done at 100 degrees Celsius. So, at this temperature most of the bacteria they are killed, and in this method we naturally uses local available material. So, no extra equipment is required for boiling. However, this method has certain disadvantages also. It can sometimes be difficult, time consuming and cost inefficient because of high volume of fuel is used. Because if we require boiled water in large scale, then this method becomes costly, because a large amount of fuel may be required for boiling. It may not remove mud from murky water, and this method cannot remove suspended or dissolved compounds. Boiling can kill only existing germs in water at the time of boiling, but does not provide any protection against future possible contamination. This step means that at the time of boiling, the bacteria which were present in water, they can be killed, but when this boiled water is stored, and after storing, if certain bacteria are produced or they may survive, then this method cannot provide any protection. This method is very costly and is applicable when water is required in small scale, that is for household purposes, and naturally it is uneconomical for municipal town water supply. Then the second method of disinfection or sterilization is chlorination. So, chlorination can be done by different methods. So, first method is by chlorine gas. For sterilization, chlorine gas or chlorine water can be used. So, how chlorine gas reacts? Chlorine gas, it reacts with water and it forms an acid which is called as hypochlorous acid and nascent oxygen, which is atomic oxygen, and the two are powerful germicides. So, this is chlorine, it can be in the form of gas or it can be in the form of liquid. It reacts with water, hydrochloric acid and hypochlorous acid. This hypochlorous acid, it further dissociates into HCl and nascent oxygen. Nascent oxygen and hypochlorous acid both are germicides. Liquid chlorine is most effective when applied to filtered water at such a point where adequate mixing is done. Chlorine is most widely used disinfectant throughout the world. So, this chlorine, it is a most widely used disinfectant, and apparatus used for this purpose is known as chlorinator. What is now? Let us have a look on chlorinator. It is a high tower, it is having a number of baffled